Picture this, an endless void, darker than the deepest ocean, stretching farther than the human mind can comprehend. Out there, in the infinite expanse of deep space, lies a realm of mysteries so vast and terrifying that they defy imagination. From black holes that devour light to rogue planets wandering in eternal darkness, the universe is filled with phenomena that are as fascinating as they are frightening. Today, we're diving into the unknown to uncover the top 20 scariest things lurking in the depths of space. These cosmic wonders aren't just the stuff of science fiction. They're real, they're powerful, and they remind us just how small we are in the grand scheme of the universe. So, buckle up and prepare to explore the eerie, the unexplained, and the utterly terrifying. By the end of this journey, you'll see the stars in a whole new light, and maybe even feel a chill run down your spine. Let's begin. Now turning to the first and perhaps most infamous terror of deep space, black holes. These cosmic monsters are the ultimate devourers, with gravitational forces so strong that not even light can escape their grasp. Imagine a region of space where the laws of physics as we know them break down, where time slows to a crawl, and where anything that crosses the boundary known as the event horizon is lost forever. Black holes form when massive stars collapse under their own gravity at the end of their life cycles, creating a singularity, a point of infinite density where the rules of the universe no longer apply. But the horror doesn't stop there. If you were unfortunate enough to get too close, you'd experience something called spaghettification. That's right, your body would be stretched into a long, thin strand like a piece of spaghetti as the black hole's gravity pulls harder on your feet than your head. It's a gruesome thought, but it's the reality of these cosmic predators. Black holes are not just destructive, they're also mysterious. Scientists are still trying to understand what happens inside them, where the known laws of physics cease to exist. So, while they may be terrifying, black holes also remind us of the endless mysteries waiting to be uncovered in the vast, dark expanse of space. Now turning to the next chilling phenomenon in our journey through the scariest things in deep space, rogue planets. These are the cosmic nomads of the universe, wandering endlessly through the void without a star to call home. Imagine a planet cold and dark, drifting through the endless expanse of space, completely untethered from any solar system. Unlike the planets we're familiar with, rogue planets don't orbit a star. They're free-floating, and their existence is as eerie as it is fascinating. But what makes rogue planets truly terrifying is their potential for chaos. Without a star to guide their path, these planets could collide with other planets or even entire solar systems. Picture a massive, icy world hurtling through space, unseen and undetected, until it smashes into another celestial body. The sheer force of such a collision could be catastrophic, wiping out entire worlds in an instant. And then there's the darkness. Rogue planets drift in eternal night, far from the warmth and light of any star. Their surfaces are frozen wastelands where temperatures plunge to unimaginable lows. But what's even more unsettling is the possibility that these planets could harbor unknown dangers. Could there be life forms adapted to such extreme conditions? Or perhaps ancient, dormant threats waiting to be awakened? The idea of a rogue planet, silent and unseen, lurking in the darkness of space, is enough to send shivers down your spine. Rogue planets remind us that the universe is full of unpredictable and mysterious forces, and that even in the vast emptiness of space, danger can come from the most unexpected places. As we continue our exploration of the cosmos, these wandering worlds serve as a chilling reminder of just how much we have yet to discover and how much we should fear the unknown. Now turning to the next spine-chilling phenomenon in our exploration of the scariest things in deep space, gamma-ray bursts. These are the most powerful explosions in the universe, capable of releasing more energy in a few seconds than our sun will emit in its entire lifetime. Imagine a burst of energy so intense that it outshines entire galaxies, even if only for a brief moment. gamma-ray bursts are born from the most violent events in the cosmos, such as the collapse of massive stars or the collision of neutron stars. When these cataclysmic events occur, they unleash beams of gamma radiation that can travel across billions of light years. But what makes gamma-ray bursts truly terrifying is their destructive potential. A single burst, if close enough, could strip a planet of its atmosphere, leaving it barren and lifeless. The intense radiation would fry any living organism, wiping out entire ecosystems in an instant. One of the most famous gamma-ray bursts occurred in the year 1998, when a burst from a distant galaxy was so bright it could be seen with the naked eye despite being billions of light years away. Scientists estimate that if such a burst were to happen within a few thousand light years of Earth, the consequences would be catastrophic. Our atmosphere would be ionized, leading to a chain reaction of chemical changes that could devastate life as we know it. The unsettling truth is that gamma-ray bursts are unpredictable. They can happen anywhere at any time, and we would have little to no warning. While the likelihood of a burst hitting Earth is low, the sheer scale of their power reminds us of the fragility of our existence in the vast, chaotic universe. As we continue to uncover the mysteries of deep space, gamma-ray bursts stand as a stark reminder of the immense forces at play, forces that could, in an instant, change the fate of worlds. Now turning to the next enigmatic force in our journey through the scariest things in deep space, dark matter. This invisible substance makes up about 85% of the universe's total mass, yet it remains one of the greatest mysteries in modern science. Unlike ordinary matter, dark matter doesn't emit, absorb, or reflect light, making it completely invisible to our telescopes. But despite its elusive nature, we know it's there because of its gravitational effects on the cosmos. Dark matter's presence is revealed through the way it bends and distorts the light from distant galaxies, a phenomenon known as gravitational lensing. Imagine looking at a galaxy and seeing its light stretched and warped, as if viewed through a cosmic magnifying glass. This distortion is caused by the immense gravitational pull of dark matter, which acts like an invisible scaffold holding galaxies and galaxy clusters together. Without it, galaxies would fly apart, unable to maintain their structure. But here's the unsettling part: we still don't know what dark matter actually is. It doesn't interact with light or any form of electromagnetic radiation, and it doesn't collide with ordinary matter in any detectable way. Scientists have proposed various theories, from exotic particles to hidden dimensions, but so far none have been proven. This means that most of the universe's mass is made up of something we can't see, touch, or fully comprehend. The implications of dark matter are profound. It shapes the large-scale structure of the universe, influencing how galaxies form and evolve. Yet, its invisible nature leaves us with more questions than answers. What if dark matter harbors properties we haven't even imagined? Could it pose a threat to our understanding of physics, or even to life itself? As we peer deeper into the cosmos, dark matter stands as a haunting reminder of how much we still have to learn about the universe and the unseen forces that govern it. Now turning to another mysterious force that shapes the cosmos, dark energy. While dark matter holds galaxies together, dark energy is the enigmatic force pushing the universe apart at an ever-increasing rate. Discovered in the late 1990s, dark energy makes up about 68% of the universe's total energy content, and its existence has completely reshaped our understanding of the cosmos. Unlike gravity, which pulls objects together, dark energy acts as a repulsive force, causing the fabric of space itself to stretch. This accelerated expansion means that galaxies are moving away from each other faster and faster over time. But here's the chilling part: we don't know what dark energy actually is. It's not made of particles like ordinary matter, and it doesn't interact with light or any other form of radiation. It's simply a property of space itself, an invisible force that defies our current understanding of physics. the implications of dark energy are both fascinating and terrifying. If this expansion continues unchecked, it could lead to a scenario known as the Big Rip. In this hypothetical endgame, dark energy would grow so powerful that it would overcome all other forces in the universe. Galaxies would be torn apart, stars would be ripped from their systems, and even atoms would be shredded as the fabric of space itself is stretched to its breaking point. The universe would end not with a bang, but with a silent, cold, and irreversible disintegration. But the mystery doesn't end there. Some scientists speculate that dark energy might not be constant. What if it grows stronger over time, accelerating the universe's expansion even faster? Or what if it fluctuates, leading to unpredictable changes in the cosmos? These questions highlight just how little we understand about this invisible force that dominates the universe. Dark energy serves as a stark reminder of how much of the universe remains hidden from us. It's a force that could one day determine the ultimate fate of everything we know, yet it remains as elusive as ever. As we continue to explore the cosmos, dark energy stands as one of the most profound and unsettling mysteries, challenging us to rethink our place in the vast, ever-expanding universe. Now turning to another cosmic phenomenon that defies imagination, neutron stars. These incredibly dense remnants of supernova explosions are among the most extreme objects in the universe. Imagine crushing the mass of our Sun into a sphere just 12 miles across. That's the mind-bending density of a neutron star, where a single teaspoon of its material would weigh billions of tons on Earth. But density isn't the only terrifying feature of neutron stars. Their magnetic fields are equally staggering, reaching strengths trillions of times more powerful than Earth. These intense magnetic fields can accelerate particles to nearly the speed of light, creating beams of radiation that sweep across the cosmos like cosmic lighthouses. When these beams point toward Earth, we detect them as pulsars, rapidly flickering signals that mark the presence of these spinning stellar corpses. However, the most fearsome type of neutron star is the magnetar. These rare objects possess magnetic fields 1,000 times stronger than ordinary neutron stars. To put this into perspective, if a magnetar were located halfway between Earth and the Moon, its magnetic field would erase the data from every credit card on our planet. But the real danger lies in their ability to unleash catastrophic bursts of energy. A single magnetar flare can release more energy in a fraction of a second than our Sun emits in 100,000 years. Such an event, even from thousands of light years away, could strip away a planet's atmosphere, leaving it barren and lifeless. The sheer power of neutron stars and magnetars serves as a chilling reminder of the violent forces at work in the universe. These objects are not just remnants of stellar death. They are active, dynamic, and capable of unleashing destruction on a scale that's almost incomprehensible. As we continue to study these cosmic powerhouses, we're left in awe of their ferocity and the mysteries they hold, reminding us just how small and fragile we are in the grand tapestry of the cosmos. Now turning to one of the most awe-inspiring and destructive events in the universe, supernovas. These colossal explosions mark the violent deaths of massive stars, releasing energy on a scale that's almost impossible to comprehend. Imagine a single star millions of times brighter than our Sun, detonating in a fiery blaze that outshines entire galaxies for weeks. That's the staggering power of a supernova. But what makes supernovas truly terrifying is their potential to wreak havoc on a cosmic scale. If a supernova were to occur within a few dozen light years of Earth, the consequences would be catastrophic. The intense radiation and shockwaves could strip away our planet's ozone layer, exposing all life to deadly ultraviolet rays from the Sun. The resulting gamma-ray burst, if aimed directly at Earth, could trigger mass extinctions, wiping out entire ecosystems in an instant. It's a chilling reminder of how fragile our existence is in the face of such cosmic forces. Yet, despite their destructive power, supernovas also possess an eerie beauty. The remnants of these explosions, glowing clouds of gas and dust, create some of the most stunning sights in the universe. These remnants, often spanning hundreds of light years, serve as cosmic graveyards where new stars and planets can eventually form. It's a poetic cycle of destruction and creation, reminding us that even in the darkest moments, the universe finds a way to rebuild. The sheer scale and power of supernovas leave us in awe, not just of their destructive potential, but also of their role in shaping the cosmos. These explosions are not just the end of a star's life. They are the birthplaces of new elements, the seeds of future worlds, and the driving force behind the evolution of galaxies. As we gaze at the remnants of these cosmic fireworks, we're reminded of the delicate balance between creation and destruction that defines the universe. Now turning to one of the most dazzling yet unsettling phenomena in the universe, quasars. These cosmic powerhouses are among the brightest objects in existence, fueled by supermassive black holes at their cores. Imagine a single object so luminous that it can outshine an entire galaxy, emitting energy equivalent to trillions of stars combined. That's the staggering brilliance of a quasar. But what makes quasars truly awe-inspiring is their source of power. At the heart of every quasar lies a supermassive black hole, devouring matter at an incredible rate. As gas, dust, and even stars spiral into the black hole, they heat up to extreme temperatures, releasing torrents of energy in the form of light, radio waves, and X-rays. This process creates a beacon of light that can be seen across billions of light years, making quasars some of the most distant objects we've ever observed. Yet the sheer power of quasars is also what makes them unsettling. These objects are so energetic that they can influence the evolution of entire galaxies. The intense radiation and powerful jets emitted by quasars can strip away gas and dust from surrounding regions, halting star formation and reshaping the structure of galaxies. It's a reminder of how even the most distant and seemingly isolated objects in the universe can have a profound impact on their surroundings. Despite their destructive potential, quasars also offer a glimpse into the early universe. Because they are so bright, we can observe them at incredible distances, allowing us to study the conditions of the cosmos billions of years ago. Quasars serve as cosmic time capsules, helping us piece together the history of galaxy formation and the evolution of supermassive black holes. The brilliance of quasars is both a marvel and a mystery, showcasing the immense power of supermassive black holes and the dynamic forces that shape the universe. As we study these luminous giants, we're reminded of the delicate balance between creation and destruction and the awe-inspiring scale of the cosmos. Now turning to one of the most perplexing mysteries in the cosmos, the Great Attractor. Hidden behind the dense band of stars and dust in our own Milky Way galaxy, this gravitational anomaly exerts an invisible pull so powerful that it's dragging entire galaxies, including our own, toward it. Imagine a force so immense that it can influence the motion of galaxies across hundreds of millions of light years, yet remains shrouded in mystery due to its elusive location. The Great Attractor lies in the direction of the constellation Centaurus, but its exact nature is difficult to study because it's obscured by the Milky Way's galactic plane. This region, known as the zone of avoidance, blocks much of the visible light from reaching us, making it a challenge for astronomers to observe directly. Despite this, scientists have used X-ray and radio telescopes to peer through the cosmic veil, revealing a concentration of mass so vast that it defies easy explanation. What makes the Great Attractor truly unsettling is the idea that it represents an unknown force shaping the structure of the universe on a grand scale. It's not just a single object, but a region of space where galaxies are being drawn together, hinting at a larger cosmic web of gravity and matter that we're only beginning to understand. This gravitational pull is part of what's known as the Laniakea supercluster, a massive collection of galaxies that includes our own Milky Way, all moving toward the Great Attractor as part of a cosmic flow. The existence of the Great Attractor raises profound questions about the nature of the universe. What lies at its core? Is it a supercluster of galaxies, a massive black hole, or something entirely different? And what does its influence tell us about the fate of our own galaxy? As we continue to study this enigmatic force, we're reminded of how much of the universe remains hidden from our view, waiting to be uncovered. The Great Attractor is a humbling reminder of the vast, interconnected nature of the cosmos, where even the most distant and mysterious forces can shape the destiny of galaxies. It's a testament to the enduring allure of the unknown, driving humanity's quest to explore the deepest mysteries of the universe. Now turning to the haunting emptiness of cosmic voids, vast regions of space where almost nothing exists. These voids are not just empty patches, they are colossal expanses, some stretching hundreds of millions of light years across, containing little to no galaxies, stars, or even dark matter. Imagine a place so devoid of matter that it feels like the universe itself has forgotten it exists. The eerie nature of these voids lies in their sheer emptiness. Unlike the bustling clusters of galaxies or the swirling chaos of black holes, voids are silent, dark, and profoundly isolated. They are the antithesis of everything we associate with the cosmos: no light, no heat, no life. Just an endless, cold expanse that seems to stretch into infinity. What makes cosmic voids truly unsettling is the idea of being lost within one. Picture a spaceship drifting into a void, its instruments detecting nothing but emptiness in every direction. No stars to navigate by, no planets to land on, just an infinite, unchanging darkness. The isolation is almost unimaginable, a reminder of how vast and indifferent the universe can be. Scientists believe these voids formed as a result of the universe's expansion, where matter clumped together in some regions, leaving others nearly empty. They are not just gaps but integral parts of the cosmic web, the large-scale structure of the universe. Yet their emptiness challenges our understanding of space and time, forcing us to confront the unsettling reality that much of the universe is not just unknown but profoundly empty. Cosmic voids are a stark reminder of the scale of the cosmos, where even the absence of matter can be as awe-inspiring as its presence. They invite us to ponder the mysteries of existence and the vast, uncharted territories that lie beyond our reach. As we explore these voids, we are reminded that the universe is not just a place of wonder but also of profound solitude, where the silence of the void echoes the questions we have yet to answer. With the next phase of the journey in sight, we move from the emptiness of cosmic voids to another chilling phenomenon in deep space, where the mysteries only deepen. Now turning to the Fermi paradox, one of the most perplexing and chilling questions in the search for extraterrestrial life. Despite the universe being unimaginably vast, with billions of galaxies and trillions of stars, we have yet to find any definitive evidence of intelligent life beyond Earth. This paradox, named after physicist Enrico Fermi, forces us to confront a haunting question: where is everyone? The sheer scale of the universe suggests that life should be abundant. With so many planets in the habitable zones of their stars, the odds seem to favor the existence of other civilizations. Yet our telescopes and probes have found nothing but silence. This eerie absence raises unsettling possibilities. One of the most discussed theories is the Great Filter, a hypothetical barrier that prevents civilizations from reaching a stage where they can communicate across the stars. The filter could lie in our past, meaning that the emergence of intelligent life is extraordinarily rare, or even more chillingly, it could lie in our future, suggesting that advanced civilizations inevitably destroy themselves before they can make contact. The idea that civilizations might self-destruct is deeply unsettling. Whether through nuclear war, environmental collapse, or some other catastrophic event, the possibility that intelligence leads to its own downfall is a sobering thought. It forces us to reflect on our own trajectory as a species. Are we destined to follow the same path, or can we find a way to overcome the challenges that lie ahead? The Fermi paradox also invites us to consider the possibility that we are alone in the universe, a solitary spark of consciousness in an otherwise lifeless cosmos. This thought is both humbling and terrifying, as it underscores the fragility of life and the immense responsibility we bear as its potential stewards. As we continue to search the stars for signs of others, the silence we encounter may be the most profound message of all, a reminder of how precious and rare life truly is. With the next phase of the journey in sight, we move from the haunting questions of the Fermi paradox to another cosmic mystery, where the universe's secrets grow even darker. Now turning to the concept of the heat death of the universe, we delve into one of the most chilling predictions for the ultimate fate of our cosmos. Imagine a universe where all stars have burned out, all galaxies have faded into darkness, and every source of energy has been exhausted. This is the heat death, a state where the universe reaches maximum entropy and no work can be done. It's a scenario where time itself becomes meaningless as nothing changes, nothing moves, and nothing lives. The heat death arises from the second law of thermodynamics, which states that entropy or disorder in a closed system always increases over time. In the universe, this means that energy will eventually spread out so evenly that no usable energy remains. Stars will exhaust their fuel, black holes will evaporate, and even the smallest particles will decay into nothingness. What's left is a cold, lifeless expanse where the temperature approaches absolute zero and the universe becomes a vast, empty void. This idea is deeply unsettling because it suggests that all the complexity, beauty, and life we see around us is temporary. The galaxies, stars, and planets we marvel at today will one day fade into oblivion, leaving behind a universe that is utterly silent and still. The heat death is not a violent end like a supernova or a black hole collision, but a slow, inevitable decline into nothingness. It's a reminder that even the universe itself is not eternal. Yet there's a strange kind of beauty in this concept. The heat death represents the ultimate equilibrium, a state where everything is perfectly balanced, even if that balance is one of complete stillness. It forces us to confront the impermanence of existence and the fleeting nature of life. As we ponder this distant future, we're reminded to cherish the time we have and the wonders of the universe while they last. With the next phase of the journey in sight, we move from the cold, silent fate of the universe to another cosmic mystery, where the forces of creation and destruction collide in a dramatic finale. Now turning to the Big Crunch, we explore a theory that stands in stark contrast to the heat death of the universe. Instead of fading into cold, silent oblivion, the Big Crunch envisions a dramatic and violent end to everything we know. Imagine the universe, which has been expanding since the Big Bang, suddenly reversing its course. Galaxies, stars, and planets would begin to move closer together, pulled by gravity until everything collapses into a single, infinitely dense point, a singularity. This is the Big Crunch, a cosmic doomsday scenario where the universe folds in on itself. The idea of the Big Crunch hinges on the balance between the universe's expansion and the pull of gravity. If the force of gravity were to overcome the expansion, the universe would stop growing and start contracting. Over billions of years, galaxies would collide, stars would be torn apart, and even atoms would be crushed under the immense pressure. Eventually, all matter and energy would be compressed into a point smaller than the tip of a pin, erasing everything that ever existed. What makes the Big Crunch particularly terrifying is the sheer scale of destruction. It's not just the end of life or planets, it's the end of space and time itself. The universe as we know it would cease to exist, leaving behind only a singularity, a state of infinite density and zero volume. Some theories suggest that this singularity could trigger another Big Bang, creating a new universe in an endless cycle of birth, death, and rebirth. This cyclical nature of the universe is both fascinating and unsettling, as it raises questions about whether our universe is just one in an infinite series. The Big Crunch forces us to confront the impermanence of existence in a different way than the heat death. While the heat death is a slow, quiet fade into nothingness, the Big Crunch is a violent, chaotic collapse. It's a reminder that the universe is governed by forces far beyond our control, and that even the grandest structures, galaxies, stars, and planets, are ultimately fragile. As we ponder the Big Crunch, we're left with a sense of awe and unease. The idea of the universe collapsing into a singularity is both terrifying and mesmerizing, a testament to the power and mystery of the cosmos. With this in mind, we turn to the next chapter of our journey, where we explore the icy, distant reaches of the Oort cloud and the hidden threats it may hold. Now turning to the Oort cloud, we venture into one of the most mysterious and distant regions of our solar system. This vast, icy shell surrounds the Sun far beyond the orbit of Neptune, stretching nearly halfway to the nearest star. The Oort cloud is home to trillions of icy bodies, remnants from the formation of the solar system over 4.5 billion years ago. These objects, ranging from tiny chunks of ice to massive comets, drift in the cold, dark reaches of space, largely undisturbed, until something nudges them out of their frozen slumber. What makes the Oort cloud particularly eerie is its role as a cosmic reservoir of potential threats. Occasionally, gravitational interactions with passing stars or the Milky Way's tidal forces can send these icy bodies hurtling inward toward the Sun. When this happens, they become long-period comets, streaking through the inner solar system with tails of gas and dust. While these comets can be breathtaking to observe, they also carry a hidden danger. A collision with a large comet from the Oort cloud could have catastrophic consequences for Earth, potentially triggering mass extinctions or global climate disruptions. The most unsettling aspect of the Oort cloud is its unpredictability. Because it lies so far from Earth, up to 100,000 times the distance between the Earth and the Sun, it's nearly impossible to observe directly. This means we have no way of knowing exactly what's lurking out there or when the next icy visitor might come our way. The Oort cloud serves as a chilling reminder that our solar system is not as isolated or secure as it might seem. It's a vast, shadowy frontier filled with ancient relics that could one day reshape the fate of our planet. As we contemplate the Oort cloud, we're reminded of the delicate balance that keeps Earth safe from cosmic hazards. This distant, icy realm is a testament to the dynamic and ever-changing nature of our solar system, where even the most remote objects can have profound implications for life on Earth. With this in mind, we move forward to explore another enigmatic region of space, the Kuiper Belt, where icy bodies and hidden dangers continue to captivate and unsettle us. Now turning to the Kuiper Belt, we find ourselves exploring another icy frontier of our solar system, one that lies just beyond the orbit of Neptune. This vast, donut-shaped region is home to countless icy bodies, ranging from small chunks of frozen material to dwarf planets like Pluto. The Kuiper Belt is often described as a cosmic junkyard, filled with remnants from the early days of the solar system, preserved in the deep freeze of space for billions of years. What makes the Kuiper Belt particularly intriguing and unsettling is its potential to send objects hurtling toward the inner solar system. While most of these icy bodies remain in stable orbits, gravitational interactions with Neptune or other large objects can occasionally disrupt their paths. When this happens, they can be flung inward, becoming short-period comets that streak through the skies of Earth. These comets, while beautiful to observe, carry a hidden danger. A collision with a large Kuiper Belt object could have devastating consequences, potentially triggering global catastrophes similar to those caused by impacts from the Oort cloud. The Kuiper Belt also holds a chilling mystery, the possibility of unknown objects lurking in its depths. Despite decades of exploration, we've only scratched the surface of this distant region. There could be massive, undiscovered bodies orbiting in the shadows, waiting to be found. The idea that something large and potentially hazardous could be hiding just beyond our view is both thrilling and unnerving. It's a reminder that even in our own cosmic backyard, there are still secrets waiting to be uncovered. As we peer into the Kuiper belt, we're reminded of the dynamic and unpredictable nature of our solar system. This icy realm, with its ancient relics and hidden dangers, serves as a testament to the ever-changing cosmos. It's a place where the past and present collide, and where the future of our planet could be shaped by forces we're only beginning to understand. With this in mind, we turn our gaze to the next cosmic mystery, where the vastness of space continues to reveal its secrets and its terrors. Now turning to the Andromeda collision, we find ourselves staring into the distant future of our galaxy, a future that is both awe-inspiring and deeply unsettling. The Milky Way, our cosmic home, is on a collision course with the Andromeda Galaxy, the largest galaxy in our local group. This event, which will unfold over billions of years, is not a matter of if but when. And while it might sound like the plot of a science fiction movie, it's a very real cosmic inevitability. When these two galaxies collide, the process will be anything but orderly. Galaxies are not solid objects, they are vast collections of stars, gas, and dust held together by gravity. As the Milky Way and Andromeda draw closer, their gravitational forces will begin to pull and twist each other, creating a chaotic dance of destruction and creation. Stars will be flung out of their orbits, some hurled into the void of intergalactic space, while others will collide or merge, igniting new stellar formations. The night sky, as we know it, will be utterly transformed. What's truly eerie about this event is the scale of time involved. The collision itself will take billions of years to complete, and by the time it's over, the two galaxies will have merged into a single, larger galaxy, often referred to as Milkomda or Milkdromda. For any life that might exist during this time, the process will be both slow and spectacular. The skies would gradually fill with new stars, glowing nebulae, and the remnants of galactic destruction. Yet, despite the chaos, the likelihood of stars or planets actually colliding is incredibly low, given the vast distances between them. This galactic merger serves as a humbling reminder of the impermanence of the universe. Even something as seemingly eternal as a galaxy is subject to change, shaped by forces far beyond our control. As we contemplate the Andromeda collision, we're left with a mix of wonder and unease: wonder at the beauty of cosmic evolution, and unease at the thought of our place in a universe that is constantly in flux. With this in mind, we turn our attention to the next mystery, where the vastness of space continues to reveal its secrets and its terrors. Now turning to the Boötes Void, we venture into one of the most unsettling regions of the cosmos, a place where the universe seems to hold its breath. Known as one of the largest voids ever discovered, the Boötes Void spans an astonishing distance of around 330 million light-years across. To put that into perspective, if you were to place our Milky Way galaxy in the center of this void, you'd have to travel for millions of light-years in any direction before encountering another galaxy. It's a staggering expanse of almost nothingness, a cosmic desert on a scale that defies imagination. What makes the Boötes Void so eerie is its emptiness. Unlike the densely packed regions of space filled with stars, galaxies, and nebulae, this void contains only a handful of galaxies scattered across its vast expanse. Scientists estimate that there are only about 60 galaxies in this region, a number that pales in comparison to the thousands typically found in similar-sized areas of the universe. This extreme scarcity of matter has led astronomers to dub it the Great Nothing, a name that perfectly captures its haunting nature. The existence of such a void raises unsettling questions about the structure of the universe. Why does this region have so few galaxies? Is it the result of some ancient cosmic event? or is it simply a quirk of how matter was distributed after the Big Bang? The truth is, we don't fully understand why the Boötes void exists, and that uncertainty only adds to its mystique. It's a reminder that even in a universe teeming with stars and galaxies, there are places where the fabric of reality seems to unravel, leaving behind a chilling emptiness. For those who dare to imagine what it would be like to travel through the Boötes void, the experience would be profoundly isolating. Picture yourself drifting through this vast, dark expanse with no stars to guide you and no galaxies to break the monotony of the void. The silence would be absolute, the darkness unending. It's a scenario that taps into one of humanity's deepest fears, the fear of being utterly alone in an indifferent universe. As we contemplate the Boötes void, we're reminded that the cosmos is not just a place of light and life, but also of shadow and silence. It challenges our understanding of the universe and forces us to confront the unsettling reality that there are still vast, uncharted regions waiting to be explored. With this in mind, we turn our gaze to the next mystery, where the universe continues to reveal its secrets and its terrors. Now turning to the red giant phase, we explore a future that is both inevitable and unsettling. A time when our own sun will transform into a red giant, reshaping the solar system as we know it. In about 5 billion years, the sun will exhaust the hydrogen fuel in its core, causing it to expand dramatically. This expansion will mark the beginning of its red giant phase, a period when the sun will swell to hundreds of times its current size, engulfing the inner planets, including Mercury, Venus, and ultimately Earth. Imagine the sun, no longer the familiar, life-giving star we see today, but a colossal, fiery sphere dominating the sky. Its surface will stretch outward, consuming everything in its path. As it grows, the sun's outer layers will cool, giving it a reddish hue, but its core will grow hotter, intensifying the radiation it emits. The once hospitable conditions of our solar system will be replaced by a scorching, inhospitable environment. For Earth, the consequences will be catastrophic. Long before the sun reaches its maximum size, the increasing heat will evaporate our oceans, turning our blue planet into a barren, lifeless rock. The atmosphere will be stripped away, and the surface will become molten under the intense radiation. Eventually, the expanding sun will swallow Earth whole, leaving no trace of the world we once called home. This grim future raises profound questions about the fragility of life and the impermanence of our existence. The idea that our own star, the source of all life on Earth, will one day destroy it is both humbling and haunting. It's a reminder that even the most stable and familiar aspects of the universe are subject to change on a cosmic scale. Yet, the red giant phase is not just a story of destruction. It's also a testament to the dynamic nature of the cosmos. As the sun evolves, it will shed its outer layers, creating a beautiful planetary nebula that will illuminate the surrounding space. The remnants of its core will collapse into a white dwarf, a dense, Earth-sized ember that will slowly fade over billions of years. As we contemplate the sun's transformation, we're reminded of the impermanence of all things, even the stars themselves. It's a sobering thought, but also a call to appreciate the fleeting beauty of the universe and the preciousness of the time we have. With this in mind, we turn to the next mystery, where the cosmos continues to reveal its awe-inspiring and terrifying truths. Now turning to the multiverse theory, we venture into one of the most mind-bending and unsettling concepts in modern cosmology, the idea that our universe might be just one of an infinite number of universes, each with its own unique set of physical laws and realities. Imagine a cosmic tapestry where every possible outcome, every decision, and every variation of existence plays out in parallel. This is the multiverse, a theoretical framework that challenges our understanding of reality itself. At its core, the multiverse theory suggests that our universe is not alone. Instead, it could be one of countless others, each existing in its own bubble of space and time. These universes might be vastly different from our own, with alternate versions of physical constants, particles, and even life. In some, the laws of physics might allow for entirely different forms of matter and energy, while in others, the conditions could be so alien that they defy our imagination. One of the most unsettling aspects of the multiverse is the possibility of alternate versions of ourselves. In an infinite array of universes, there could be countless versions of you and me, each living out different lives based on the choices we've made or didn't make. A version of you might be a world-renowned scientist, while another might be living a completely ordinary life. The idea that every decision branches off into a new reality is both fascinating and deeply disorienting. But the multiverse isn't just a playground for science fiction. It's a serious scientific hypothesis that arises from theories like quantum mechanics and cosmic inflation. For instance, the inflationary model of the early universe suggests that rapid expansion could have created bubble universes, each with its own distinct properties. Similarly, the many worlds interpretation of quantum mechanics proposes that every quantum event spawns a new universe, leading to an ever-growing web of realities. Yet the multiverse remains a deeply controversial idea, because these other universes, by definition, lie beyond our observable horizon. They are impossible to detect or study directly. This has led some scientists to question whether the multiverse is a testable theory or merely a philosophical speculation. Still, the concept continues to captivate both scientists and the public, offering a tantalizing glimpse into the infinite possibilities of existence. As we ponder the multiverse, we're confronted with the profound question of our place in the cosmos. Are we unique, or are there infinite versions of us scattered across an unimaginable expanse of realities? The multiverse theory doesn't just challenge our understanding of the universe, it challenges our understanding of ourselves. And with that, we move to the final and perhaps most terrifying mystery of all, where the unknown looms larger than ever. Now turning to the final and perhaps most chilling entry on our list, we confront the ultimate cosmic mystery, the unknown. Despite all our advancements in science and technology, the vast majority of the universe remains unexplored, shrouded in darkness and secrecy. This is the great frontier, the endless expanse where our knowledge ends and the unimaginable begins. And it's here, in the unknown, that the true terror of deep space lies. Think about it, we've mapped only a tiny fraction of the cosmos. The observable universe stretches for billions of light years, but beyond that, there could be realms we can't even begin to comprehend. What lies in those uncharted regions? Could there be phenomena so bizarre, so alien, that they defy our understanding of physics? Or worse, could there be threats lurking in the void, waiting to be discovered? The unknown is a reminder of how small and vulnerable we are in the grand scheme of the universe. But it's not just the vastness of space that's unsettling, it's the mysteries that lie within it. Dark matter, dark energy, black holes, and other cosmic enigmas remind us that we've only scratched the surface of what's out there. Every discovery seems to raise more questions than answers, and the deeper we look, the more we realize how much we don't know. This endless quest for understanding is both thrilling and terrifying, as it forces us to confront the limits of human knowledge. And then there's the question of life. Are we alone in the universe, or is there something or someone out there in the darkness? The Fermi paradox looms large here, reminding us that the absence of evidence is not evidence of absence. If intelligent life exists, why haven't we found it? Could it be hiding in the unexplored reaches of space, or are we simply not looking in the right places? The unknown holds the answers, but it also holds the potential for unimaginable discoveries and dangers. Yet, despite the fear it inspires, the unknown is also what drives us forward. Humanity's insatiable curiosity pushes us to explore, to probe the depths of space in search of answers. From the first time we looked up at the stars to the cutting-edge telescopes and probes of today, we've always sought to uncover the secrets of the cosmos. And while the unknown may be terrifying, it's also a source of endless wonder, a reminder that the universe is far more complex and mysterious than we can ever fully grasp. As we conclude our journey through the top 20 scariest things in deep space, we're left with a profound sense of awe and unease. The universe is a place of beauty and terror, of light and darkness, of the known and the unknown. And it's this duality that makes it so endlessly fascinating. So, what do you think is the most frightening cosmic phenomenon? Share your thoughts in the comments below, and don't forget to subscribe for more explorations of the universe's greatest mysteries. Until next time, keep looking up and remember, the stars hold secrets we've only begun to uncover. Now turning to the conclusion of our journey through the top 20 scariest things in deep space, let's take a moment to reflect on the terrifying yet awe-inspiring phenomena we've explored. From the all-consuming power of black holes to the eerie emptiness of cosmic voids, each entry on this list reminds us of the vast, mysterious, and often unsettling nature of the universe. These cosmic wonders are not just sources of fear, they are also gateways to understanding the incredible complexity of the cosmos. We've delved into the destructive potential of gamma-ray bursts, the enigmatic forces of dark matter and dark energy, and the chilling implications of the Fermi paradox. We've marveled at the chaotic beauty of supernovas, the immense power of quasars, and the inevitable collision of galaxies. And we've confronted the ultimate mystery, the unknown, that vast, unexplored frontier where the universe's greatest secrets may lie hidden. Each of these phenomena challenges our understanding of reality and reminds us of how much we have yet to discover. But what makes these cosmic wonders truly fascinating is their duality. They are both terrifying and beautiful, both destructive and creative, both mysterious and enlightening. They remind us that the universe is a place of endless possibilities, where the boundaries of science and imagination blur. And they inspire us to keep exploring, to keep asking questions, and to keep pushing the limits of what we know. So, what do you think is the most frightening thing in deep space? Is it the thought of being swallowed by a black hole, the idea of a rogue planet colliding with Earth, or the eerie silence of the Fermi paradox? Share your thoughts in the comments below. We'd love to hear which cosmic phenomenon sends shivers down your spine. If you've enjoyed this journey through the scariest things in deep space, don't forget to subscribe to our channel for more explorations of the universe's greatest mysteries. Hit the notification bell so you never miss an update, and give this video a like if you found it as fascinating as we did. Until next time, keep looking up at the stars, and remember, the universe is full of wonders waiting to be discovered. Thanks for watching, and we'll see you in the next video.